Welcome to The Explainer. Let's get right into it because there is a massive, high-stakes business drama unfolding literally right above our heads. The race to build the first commercial electric air taxis, what we call eVTOLs, or electric vertical takeoff and landing aircraft, is officially on. It's a technological revolution that's going to completely change urban transit as we know it. But as we look past the shiny prototypes and step into the boardrooms, you might be surprised to find that the ultimate winner of this race might not be who you expect.
Okay, here's our roadmap for today. We'll start with the flying car race, look at the billion-dollar certification hurdle, tackle the first-of-type penalty, dive into the second-mover advantage, and wrap things up with the future of eVTOL skies.
All right, part one, the flying car race and the overall market.
To truly understand this corporate battle, we've got to look at the sheer scale of the new advanced air mobility market. We're talking about a completely new era of air transit, using highly automated electric aircraft. In the US alone, this market is projected to hit a staggering $115 billion annually by 2035. That is a massive financial pie, which brings us to a really fundamental question. Who actually wins the flying car race? It's totally natural to assume the first company to launch an air taxi is the guaranteed runaway winner, right? They get the glory, the press, the government backing, the early adopters. But, business history, and especially aviation history, tells us a much more complicated story.
Right now, we've got the first wave heavyweights pushing the absolute limits of what's possible. We're talking about companies like Joby Aviation, Archer Aviation, Beta Technologies, and Lilium. These are your trailblazers. Just look at their testing milestones in 2025. Beta Technologies logged over 100,000 nautical miles in real-world testing. Joby nailed these incredible piloted transitions, moving seamlessly from a vertical hover right into forward wing-borne flight. And Archer? They took their Midnight aircraft to a record altitude of 10,000 feet. They are out there doing the incredibly hard, hands-on work of proving this tech actually functions.
Moving on to Section 2, the billion-dollar certification hurdle. As mind-blowing as those flight tests are, honestly, getting off the ground is just half the battle. The other half? That is the grueling regulatory nightmare these pioneers have to survive before they're legally allowed to fly a single paying passenger. We're talking about type certification. Let's demystify this real quick. Type certification is the rigorous process where the FAA verifies that an aircraft's design meets their ultra-strict performance and structural safety standards. But here is the kicker for eVTOLs. Because these are radically novel aircraft using electric propulsion, weird new battery chemistries, and advanced autonomy, there is literally no existing rulebook. So the pioneers aren't just studying for a test, they are actively helping the FAA write the test while they're sitting in the exam room. Take the W-shaped development cycle, for example. It brilliantly captures the absolute headache required just to validate the systems on these aircrafts. It was specifically created for certifying neural networks and AI in aviation, and it shows that unlike your standard software, you can't just write some code for a machine learning vision system and call it a day. You have to meticulously grind through data collection, model learning, implementation, and this massive verification process. It is an incredibly tedious, multi-stage grind just to prove to regulators that the autonomy blocks won't fail mid-flight. To really put that into perspective, let's compare aviation's DO 178C standard to the automotive ISO 26262 standard. Aviation safety standards are exponentially stricter. Think about it. If the self-driving software in your car glitches, you just pull over to the shoulder. In aviation, a software failure can be absolutely catastrophic. So proving that an electric semi-autonomous flying taxi meets these top-tier DO 178C standards is a monumental task. Which brings us to Section 3, the first-of-type penalty and its hidden costs. This is the core strategic tension of the entire eVTOL market right here. There is a massive hidden financial cost to being the first one to take a machete and hack through this regulatory jungle. And that cost is $1.5 billion. According to public documents, pioneers like Joby, Archer, and Lilium are projecting total development cost of around $1 to $1.5 billion each just to reach type certification. That is an astronomical barrier to entry for any startup, no matter how well-funded they are. Now, what's really fascinating is where that money actually goes. You'd probably assume the vast majority of that $1 billion goes into building futuristic factories or buying exotic materials, right? Well, analysis shows that an estimated 35 to 50%, let's call it an average of 45%, of a developer's costs go purely toward proving airworthiness to the FAA, almost half the budget.
It's the cost of endless paperwork, redundant testing, validation flights, and just nonstop regulatory negotiations.
So the crucial takeaway here is that early entrants pay what industry insiders call a first-of-type penalty. Because the FAA is retrofitting existing rules, like Part 23 for airplanes and Part 27 for helicopters, to these highly unusual aircraft, the pioneers absorb the massive cost and time delays of establishing these brand-new custom certification bases. Every single unique design choice requires a new standard to be debated and codified. Essentially, they are paying top dollar for the privilege of paving the regulatory road.
And that leads us perfectly into Section 4, the second mover advantage.
So, if the pioneers are the trailblazers spending billions to build the road, the settlers are the second wave of developers, and their strategy is entirely different. The firsts face extremely high costs, agonize over custom certification bases, and basically write the rules. But the seconds, the companies coming up right behind them, get to slide in with significantly lower development costs. Because they learned directly from their predecessors' growing pains, these second-wave entrepreneurs can bring an aircraft to market with a much lower sticker price. And in aviation, a lower sticker price ultimately means greater sales and much faster fleet expansion.
Let's break down exactly how these new eVTOL makers are learning from the early certification struggles of their competitors. First off, instead of banging their heads against the wall negotiating complex, custom certification paths from scratch, the seconds simply adopt the established means of compliance that the FAA has already approved for the pioneers. Easy. Second, take battery thermal runaway, which is a massive risk for electric aviation. Instead of blowing tens of millions testing unknown battery limits, the seconds just sit back, watch what safety thresholds and chemistries the FAA gives the green light to, and bake those proven standards right into their own designs. Finally, they dodge crippling supplier certification costs by using components the pioneers have already paid to certify. These second movers act as subject matter experts. They watch the pioneers take the hits, take furious notes, and build a more cost-effective machine without stomaching the same financial risk.
Finally, Section 5, the future of eVTOL skies.
So when does all this theoretical business strategy actually hit the real world? The timelines are aggressive, to say the least. In 2024, we saw piloted transition flights safely achieved. Now in 2025, we're seeing massive, intense flight testing, with companies even coordinating with real air traffic controllers at major airports. Looking ahead to early 2026, companies expect to kick off Type Inspection Authorization, or TIA testing, where FAA test pilots actually grab the stick to evaluate the aircraft. But the massive milestone is summer 2026, the FAA's eVTOL Integration Pilot Program, or EIPP. This program will finally allow these companies to conduct real-world operations using temporary infrastructure. For the very first time, some of these pre-certified aircraft will actually be allowed to conduct revenue-generating cargo flights.
Which brings us to one final thought to leave you with. Knowing what you know now about the grueling billion-dollar certification hurdles, that punishing first-of-type penalty, and the undeniable advantage of learning from the costly mistakes of the competitors who came before you, would you rather be the pioneer who burned $1 billion to pave the road, or the driver who uses that exact same road to cruise straight to the bank? It's the ultimate business paradox of the eVTOL market. Thank you so much for hanging out with us for this explainer. Keep your eyes on the skies, and we'll catch you next time.